Hello, the other day I received a shipment with a Unihiker K10 development board from Dfrobot, which I received as a prize. The device is well packaged in a branded box, protected from damage during transportation. In fact, the device is based on a ESP32S3 Extensa LX7 microcontroller and ILI 9341 TFT display with a resolution of 320 on 240 pixels. The display is protected by a metal frame, and right above a light sensor, temperature and humidity sensor, as well as two microphones for noise reduction. There are two buttons on the side, an edge connector at the bottom for connecting additional modules and sensors. On the back there is a camera, 3 input-output connectors, a microSD slot, a speaker, 3 RGB LEDs type WS2812, an accelerometer chip, and battery interface. First, I made a 3D printed case according to the STL file provided on the manufacturer's website. The case fits perfectly on the back of the PCB and protects sensitive components. There are openings for the camera, input-output connectors, USB port, and the buttons are functional. After successful boot up, K10 runs the factory built-in programs: face detection, voice recognition, sensor mode, and view tutorial mode, which generates the QR code and through your cell phone to view the tutorial for K10. By pressing the B button, we move through the menu. This is face detection program, voice recognition, sensor mode, and view tutorial mode. As for the software, the supported environments are Mind+, Arduino IDE, and MicroPython. Basically, the K10 is designed as a device for exploring AI, IoT, and Python coding. Even all the support from internet groups and communities relates to these areas. My previous experience has only been with Arduino IDE, so I was pleasantly surprised to read that this board supported. However, I quickly learned that Arduino IDE support is limited to a single library, Unihiker K10.h. I even contacted the manufacturer regarding support for other standard Arduino libraries, but the answer was that the SDK for Arduino IDE is under development and is currently recommended to be used only in conjunction with Mind+. So I decided to do some research myself and try to install some kind of program using standard libraries. Actually, it's about an ESP32 MCU and an ILI 9341 driver-based TFT display. So it seems logical to me to start with a project that would use some known library, so I choose Bodmer's TFT ESPI. First, I downloaded and carefully studied the Unihiker K10 schematic and the way to connect the microcontroller to the display. Based on the data from this schematic, I modified user setup.h to match the specific connections. Next, I installed support in Arduino IDE for this development board as follows. We need to go to File, Preferences, Additional Board Manager, URL, and here we need to put given link. Okay. Then go to Tools, Boards Manager, and search for Unihiker. We need to install Unihiker by Dfrobot. Now the installation is completed. We need to go to Tools. Next, Unihiker, and choose Unihiker K10. With this, the support for this development board in Arduino IDE is installed. Now comes the interesting part, which is testings. First, I replaced the original user setup.ah with modified version for this board. Of course, to start, I tried installing one of the examples included in this library. And I choose TFT Meta. Upload. The example is installed successfully without errors, but unfortunately after rebooting the display remained black. I went back to the schematic and discovered that the backlight of the display is controlled by a transistor whose base is connected to a special pin on the I/O expansion chip and not directly to the microcontroller, which theoretically means that there is no chance to software turn on the backlight on the display. I could probably do it in hardware by directly connecting the ground of the LED pins, but that would be difficult to do, and there is also a chance to damage the board. I came to the solution accidentally and in the following way. First, the factory firmware is installed on the board according to the instructions provided on the site. Then, without disconnecting the board from the USB, the indicated example from the TFT ESPI library is installed, and after uploading, a beautiful analog meter appears on the screen. I assume that the same procedure works on other display libraries such as Dfrobot ILI 9341. The device is very practical and displays several parameters. The main part is the analog meter, and it displays the relative light intensity received by the sensor on a scale from 0 to 100. Here is the sensor. This value is numerically displayed on the lower left part of the instrument. Below the instrument are two important values: the raw value provided by the sensor and the range in which the instrument is currently operating. The value of the light intensity can be easily expressed in lux units using a simple formula provided by the sensor manufacturer. The real raw values for the intensity of the light from complete darkness to direct sunlight range from 0 to several tens of thousands, so if the entire range was displayed on this scale, the resolution would be extremely low. Therefore, for greater precision and flexibility of the device, I introduced auto-range minimum-maximum values which are based on the light intensity at the moment the device is turned on. For example, if the intensity at a certain moment exceeds the limits of the current set range, it will automatically change. Let's see how it looks in reality. Now the range changed from 0 to 4147. If I reset the device, also range will be resetted to current intensity of the light. In the meantime, I found a solution to the problem with the backlight on the display. I also included the library Unihiker K10.h and initialized the backlight in the void setup. So now the program just needs to be installed on the board, regardless of which program was previously installed. Also now, after turning off the board from the power supply and turning it back on, the program is activated along with the backlight turned on. And finally, a short conclusion: the successful integration of TFT ESPI and other fluid sensor libraries proves this AI-focused board has also potential for traditional microcontroller applications.